So far, we have seen modeling. We have to do identification. We did some last time. We'll go back to R later, and I'll show you, how to identify models. So model identification, the modeling part, then comes the forecasting part, and then adjusting the forecast. I don't think we'd have time to get into adjusting forecast, but forecasting is important. That's the purpose of time series. Just like regression, you want to make a prediction, right? You have a model, you make a prediction. Same logic. I guess I'll use AR2. Suppose you have an AR2 model in the sense that you observed a series. The series ends up being AR2. You identified the model to be AR2. Well, there is a question: how do we identify an AR model?
BACF.
BACF. You look at the BACF plot, and it tells you if you have two leading peaks, then it's AR2. And let's say you identified, you even fit the model. Well, what is one way to fit an AR model? We looked at two different approaches.
Durbin-Levinson.
One is Durbin-Levinson, the other Euler-Walker, right? So you could use either approach to fit. So let's say you observed a series, you identified it to be AR2, and you ended up getting fits. And I'm not going to put that error part, or perhaps I'll do it for now. I'll use epsilon. The error is nothing but the noise.
So the final will be next Thursday?
Yes.
Okay.
Last.
Can you post like a list of topics for the one, the exam this Thursday, so we know exactly, just like.
I have not written the exam yet. I'm halfway there, but I should be done by, depending on how long the ceremony goes today. Hopefully I'll be done tonight. And then I'll use one. Okay. So going back to bit of probability theory, if you took the expectation on both sides, what does expectation mean? I actually gave you the answer when I asked that question. The mean, the theoretical mean. Well, XT is a quantum variable that has some mean, typically it is 0, but it is an observed process, it depends on itself. So that can't be 0, right? It has some value, it is an observed series. So theoretically, expectation of XT will be XT. 0.89, you can pull that out. What is the expectation of XT minus 1?
XT minus 1.
XT minus 1. 0.62. Expectation of XT minus 2 would be XT minus 2. And lastly, if expectation of epsilon t, theoretically speaking, 0. How do we differentiate in a model expression versus a fitted model? There is the concept of the theoretical model and then the fitted model. Fitted is using adapted. Theoretical is what we use to derive that. So far, we just called it xt, xt minus 1, xt minus 2. But if you have to represent a fitted value, which is an estimate, how would you denote it? With a hat. This is just the notational aspect of things. We'll just put x hat. X hat simply means the estimate. X hat is an estimate for xt. You might notice that I am not using hat there. Of course, later on we can't put hats there, but I'm not doing it right now because I am looking forward to obtain a forecast. So we need to come up with something called a forecast function. Why do we need a function? Well, we have seen recursive equations with AR, with MA. So a forecast function would also be a recursive equation. So let's see. We use the letter K, H, I take K, L. Suppose L it is the lead time, not the lag. I did not use K, I did not use H because we've used H in the past, K in the past for lag, not lead. Let's use L. And forecast simply would mean you are going 1 step forward, 2 steps forward, and so on, right? So xt plus L. Good so far? Now, we need to have a series, and let's say this came from, I'll use start. I'm going to make a slight change, and you can tell me why I have to make a change after doing it in half. Let's change that to minus 0.64. Any thoughts as to why I had to change it to minus 0.64? When I put those values 0.89 and 0.62 and tried to simulate a series, I got an error because it wasn't stationary. Well, when does it happen? condition for station occupancy. Time to connect the dots. It should all come together now.
Absolutely so.
It's not absolutely summable, in other words, coefficients are probably not absolutely summable. What is the other condition?
Positive, some definitely.
Simple than that. We just so many problems on this.
Oh, the roots lie outside the unit.
The root of the characteristic polynomial lies inside, or lie inside the unit cell. So, good so far. So this comes from this simulated series. Eight time points and by 1.60, negative 1.08, negative 2.66, negative 3.59, and so on. So, we give it a letter. Forecast at lead L. When L is equal to 0, you are simply at XD, correct? So let's start with f of 0. What would your origin time points be? We have 8 time points, so XD must be t equals starting point to make that forecast. 8 values.
What's the question?
8 values in the past, including the 8th one. So where should t be, the starting point? How about 8?
Yeah, you can pick the,
But L equals 0 would mean we're starting at 8. And that is 0.89 x 8 plus 0 minus 1, so x minus 0.64 x 6. Now, do you think why I'm not putting that out? because I'm going back to values that are actually in the series, something that you've really observed. So no hat here. Plug in the values, so 0.89 times x7 1.44 minus 0.64 times x6 1.15, and what do we get? I end up getting 0.5456. I'm going to round it to 0.55. Wow, did the model do a good job? Not bad, right? Got lucky because it's a simulation perhaps. So the actual value is 0.59. We end up getting 0.55. Good. Lab 1. You're forecasting by 1 step ahead. So that was equal to 0.89 times xt, which is 8, plus 1 minus 1, you get 8, minus 0.64, 8, plus 1, 9, minus 2, we have 0. Do we have x8? Yes. Do we have x7? Yes. Okay. So 0.89 times x8 0.59 minus 0.64 times 1.44. What is that value? Approximately negative 0.40. Now, we have no clue as to what that number is, right? So I made my first forecast erase. The next step, x hat 10.89 times t is 8, L is 2, 8 plus 2, 10, 10 minus 1, you get 9. Minus 0.64, 8 plus 2, 10 minus 2, you get 8. Good. As I said, is it okay to write it as x9? Or should it go there?
Should we go to find hat?
It should be hat. So we take the previous value, so 0.89 times minus 0.40 minus 0.64 times x8, which is 0.59. What do we get? Erase. Let me just throw this away. Wait until the end of the semester to do it. Time step 11. 0.89, t is 8, 3 steps ahead, so 11 minus 1, so 10 minus 0.64, 8 plus 3 minus 2, so 2 steps backwards, 9. Is it okay to call it as 10 or x 10 and x 9? No, you've got to put had. 0.89, x hat 10 is negative 0.73. X hat 9 is negative 0.40. And what is that answer? Can I write a general expression for the forecast function f in terms of L? Look at the pattern over here. You should know or notice for lead 1, I get those two terms, lead 2, I get that. So forget about the x's, just in terms of f. Could I write, or is it possible to write or come up with an expression for f of f? Hint, what is x hat or x pen hat in terms of f? Ethan? F of 2. What is x9 hat?
F of 1.
F of 1. Any thoughts? If L is 3, then I can write it as
0.9 f squared, like a 4 operator.
erase. Just in terms of f, Joe. So f is not the forward operator, rather it's the forecast function. So f, something's got to go there. Minus 0.64 f, something else got to go there.
Would be f of L minus 1 and f of L minus 2.
Do we agree? One might wonder as to why do we want this recursive expression, or why do we want to write it this way? Well, we're dealing with time series. We know we have infinite sums, and when you have sums, it's better to have indices, right? So you can rewrite this expression as an infinite sum, that as an infinite sum, and come up with a simpler version of a sum. Yes, which is why we have the recursive equation. So that is what we call the forecast function. Let's see if it did a good job. So did we make a good estimation? So I started with 0.62, that was my initial set of coefficients, 0.89, 0.62. I got an error, not stationary, so I changed it to 0.89, negative 0.64. In practice, we started backwards, so you start with the series, the first 8 values right there, and We fit a model after identifying that it is an AR2 model. And we came up with the forecast function. The first value ends up being negative 0.14. Good? Is it a good estimate? Okay,
Why is the first value, like the values, why are they different depending on if you set ended 8 or 12?
it's random.
Oh, okay.
It's randomly generated.
Okay.
I started with 8, but then I realized I need to forecast, so let's go for 12. What was F1, which is x hat 9?
Negative 0.4.
Negative 0.4.
So now we have a different X7, X8.
Do I have a different x and then x8?
So those are the same.
It's the same.
The ones you wrote down.
Yeah, they match up, right?
Yeah.
So I get negative 0.14. The next value,
Negative 0.73.
the actual value is negative 1.15. The next value,
Negative 0.39.
I get 1.32. Right? Way off. Why?
So it's an AR2.
1 is an AR2. Also, how many observations did I have?
12.
12. And out of those 12, I just wanted to show you that, this is how we predict, which is why I generated 12. But as a practical case, technically, we observed only 8 time points. And I'm trying to predict 9, 10, and 11 based on 8 time points. Is it going to be a good prediction? Absolutely not. We need more information. So in practice, you don't just have 8 observations, you probably have, 100, 120 longer times. Good? The longer you observe, the better the prediction. Common sense, right? Are we clear?